Mercury occupies an unusual position in the solar system in more ways than one. Unlike Uranus and Neptune, Mercury is one of the first planets to be discovered dating back to prehistoric times. It's visible to the human eye, bright, but difficult to spot. It often hides behind trees near the horizon. This was most noticeable in the distant past, as it seldom rises very high over the horizon and goes quite swiftly. This is because it orbits the Sun incredibly quickly, prompting the Greeks and Romans to associate it with Hermes or Mercurius, the fast-footed messenger god of the Greco-Roman universe. However, it was known to many people around the world, including astronomers in China and the Middle East, who observed and recorded it. Mercury can be viewed in the evening or in the morning, and by 350 BC, both were recognized as the same object. We now know that Mercury is the nearest planet to the solar, which puts it in the unusual position of being tidally locked to the Sun, but not in the traditional sense of an exoplanet only displaying one face to its star. Rather, Mercury is locked to its orbital period, resulting in a 3:2 resonance and an extremely long day during a very short year. Mercury is a terrestrial, rocky planet that is the smallest planet if Pluto is excluded. However, it is substantially smaller than several of the solar system's moons, such as Ganymede and Titan, though not in mass. And that's where things become weird. Mercury's mass distinguishes it from the other planets in the solar system, and this is where the mysteries begin. Mercury's composition is unusual. It is 70% metallic and just 30% silicate rock, which is nearly the reverse of the other terrestrial planets. It's a mostly metal world, and this is bizarre. In short, Mercury appears to be more like a planetary core than a typical planet, leading to the theory that this is exactly what it is. It's probable that Mercury was substantially larger in the early solar system, around 2.5 times its current size, with a composition similar to the other terrestrial planets. It could have started in an orbit closer to Mars than it is now, potentially placing it in Earth's vicinity at one point. And this is where the first peculiarity exists. So, for all of that material to be peeled away, leaving basically just a core, Mercury would have had to crash with another sizable object early on, or several of them, according to current research, in such a way that it was glancingly pared down rather than completely destroyed. This would have sent a tremendous amount of material into the solar system, which has been tenuously related to two uncommon meteorite kinds, instatites and abrites, which may have come from the collision or impacts, although the evidence is shaky. The composition of instatites differs greatly from that of typical chondrite stony iron meteorites. Their composition shows that they formed around the inner edge of the solar system's protoplanetary disk, near or within Mercury's present orbit. There have been numerous suggestions as to what the parent body of these meteorites is, but one alternative is Mercury because they are equally metal-rich, while the other is the asteroid 16 Psyche, which is anomalously metal-rich and has a NASA mission on way to explore it. It won't be long before we learn more. Abrites are even weirder. These rocks are igneous, which means volcanic, and they often resemble moon rocks, but not enough to claim that they are the origin. They frequently contain fragments of other meteorites, implying that the parent body was involved in severe impacts. Mercury meets both of those criteria. It is similar to the Moon and is covered in impact craters. Whatever caused Mercury to be the way it is strange, because the same thing happened on Earth. The dominant scenario for the origin of the Moon is a collision between an object roughly the size of Mars called Theia and Proto-Earth, which blasted off the material that became the Moon. This condition may have been unique in the solar system in terms of Moon creation, but it clearly required a glancing hit from Proto-Earth, which Mercury also appears to have required to peel its outer layers. Protoplanetary impacts are well documented in the solar system. This is also observed with objects such as Uranus moon Miranda, which looks to have been entirely shattered at some point, most likely in another impact and then reconstructed from the parts. This reflects a large number of collisions in the solar system and may indicate that such events are prevalent early in the history of many star systems, including our own. This is supported by infrared evidence of recent collisions in young exoplanet systems. This may imply that the situation that formed the Earth-Moon system was not as unusual as it appears. possibly involving glancing blows, which would go some way toward eliminating a solution to the Fermi paradox, the rare moon hypothesis, in which the presence of a moon like Earth's is required for life. This concept has already received criticism, but in a different way. The main reason it was evoked was the belief that tidal pools are the most likely setting for life to have originated on Earth. There are no tides or quiet pools in which the chemistry can occur. That being said, removing the moon from the system would not eliminate Earth's tides. Rather, we would be left with just the weaker solar tides produced by the sun. Recent abiogenesis research, however, points to volcanic hot springs as the habitat, indicating that volcanism and liquid warm water in the universe are unlikely to be rare. Another notable mystery of Mercury is just where all of this occurred. It is unclear whether Mercury has always been in its current orbit. Hints from the Messenger spacecraft revealed that Mercury has a much higher potassium ratio than thorium. The difference between potassium and thorium is that potassium evaporates in hot environments, whereas thorium does not. When comparing these ratios to Earth, the Moon, Mars, and Venus, the ratios appear to be correct for their overall temperatures. But not for Mercury. It appears to have formed further away from the solar, and the massive collision or collisions may have occurred in that original place, with its current position near to the Sun being the result of orbital disturbance caused by the hits. However, something even odd has emerged, though it is hotly debated. It is the theory that Mercury is Theia, and the junk that has been removed from it is currently trapped in the Moon and Earth. This scenario would have needed approximately 20 Mars-sized asteroids in the early solar system colliding with and enlarging Earth and Venus. Mars is only one of those that survived by chance, while Mercury is a core relic that could be or was Theia. Proving or disproving it will necessitate a massive amount of measurement, which is scheduled to occur with the European Space Agency's Bepi-Colombo mission, which is en route to Mercury and will arrive in December 2025. That would be a game-changer in astrobiology if we get any further signals about that scenario. But if it turns out that some component of life on Earth is tied, although peripherally, to a collision with Mercury. Another subject on Bepi-Colombo's agenda is the search for water on Mercury. There are enticing clues that Mercury shares a position with the Moon, with ice-filled craters that never see sunlight and might potentially supply a water source if someone ever attempts to establish a Mercury colony. That isn't discussed much this early in the space exploration game, but if a science outpost or something similar is ever established there, it will have a known local water supply, and colonizing it will benefit from experience in lunar colonization, which is discussed and also involves craters. Because Mercury doesn't appear to be that different of an environment, at least in some respects. But there will be some differences. Mercury can be really hot. However, because Mercury is so thick, its gravity is closer to Mars than the Moon's, and we already know of one case with Mercury that looks to be unique in the solar system. Around a few of Mercury's craters are strange depressions, or hollows, that appear to be produced by something evaporating beneath them. This looks to be recent action, and no one understands why, save that some volatile appears to be rising from deep within Mercury and sublimating out at some point. These were initially observed by Messenger, and Bepi-Colombo arrives a decade later, so scientists are hoping to detect any changes that may have occurred in the interval. The Moon does not perform any of this, implying that there is active geology at Mercury, driven by an unknown process that differs from the Moon. Mercury is also very black for a solar system object. No one knows why it's so much darker than the Moon. If it replaced the Moon in the sky, it would be about 2/3 the brightness. It's possible that Mercury's surface materials darken due to the tremendous heat it experiences in comparison to the Moon. Or it may be something extremely unusual, such as graphite, which had a reason for existing there that other substances in the solar system did not. Mercury also retains a magnetic field, despite the fact that it appears to be physically too small to have one. It is quite feeble, yet it exists. Nonetheless, the larger Mars lacks this. This may indicate that Mercury's core is still molten, at least partially. Mercury appears to have a liquid layer beneath the surface, according to tidal measurements, and some geologic fissures and characteristics indicate that it is shrinking as it continues to cool. However, the reason for the core's continued molten state remains unexplained. Finally, Mercury has a very tenuous atmosphere. It's exceedingly thin, but it was a hotly disputed topic before any spacecraft visited Mercury. In terms of atmospheres, it is unique to the solar system. That same heat that should have evaporated Mercury's potassium is currently evaporating a range of things, including solar wind components that make up the atmosphere. However, the sun is also stripping the atmosphere away, so Mercury now has a comet-like tail as the evaporation and stripping process proceeds. Mercury is frequently an overlooked planet. It is extremely difficult to reach and examine, and for many years it was assumed to be a somewhat dull moon-like planet. As is often the case with the solar system, the more we study, the more interesting the objects become, and if it can be demonstrated that Mercury is actually Theia, it becomes one of the most important and formative objects in the solar system. And without it, we may not have ever existed. Without Mercury, Earth may have become a tiny Mars-like world incapable of supporting complex life. Alright folks, this video ends here. Thanks for watching. Subscribe to my channels for regular, in-depth studies of the fascinating, strange, and unknown parts of our incredible universe.